Let's go to page 66 and number 102. Number 102 says giving that 9 to the 6th power is equal to 531441. So how will you represent 531440 in base 9? Okay, so first let's go and think about this number in base 9. So sometimes it's kind of hard to do that right away. So let's say think about a number. So you got 10 to the 6. Okay, when you write this number, you're going to get 1. Now 6th power, you're going to get 6 zeros. Okay, now this is base 10. So when you have the base 10 to the 6th power with base 10 with the same base, you're going to get that. So when you have 9 to the 6, okay, with a base 9, so again, this is base 10, so same number, you're going to do that. So with the base 10, base 9, okay, so same number, so you're going to, with same result. Okay, so 9 to the 6th power in base 9 is going to be equal to 1, 0, 0, 0, 0, 0, 0, base 9. Okay, now this one in base 9, this is 1 less than that. So all you have to do is you use this over here. You just have to minus 1. Now when you minus 1, think about this one. When you minus 1, you're going to get what? So with the base 10, you got 1, 0, 0, 0, 0, 0, 0, base 10. So this is base 10. So when you minus 1, you're going to get 9, 9, 9, 9, 9, 9, right? Now because this is base 10, so 10 minus 1 will give you 9, right? This is going to be 1 less than that. But this is base 9. So that means when you minus, this is actually worth, this is, each one of this is worth 9, right? So when you minus, you actually is 8. So it's going to be 1 less than that, right? So you're going to get 8, 8, 8, 8, 8, 8, okay? And this is base 9. So again, when you borrow, it does not equal to 10. When you borrow 1, this becomes 9. And you borrow, it becomes 9. Borrow, it becomes 9, and you subtract. So you're going to end up with 8888. So this should be your answer. So 531440 is going to equal to that in base 9. Okay. Okay, let's go to 103. It's a find the smallest positive integer greater than 1, which yields a remainder of 1. Remainder of 1 when divided by any single digit positive integer greater than 1. So single digit positive integer greater than 1 would be 2, 3, 4, 5, 6, 7, 8, 9. Okay? So you have this kind of similar type of problem before. So you can let it n equal to the number. So you're going to get 1 mod 2, 1 mod 3, 1 mod 4. So you're going to have so you're going to yield a remainder of 1 when divided by any single digit positive integer, okay, greater than 1. Okay, so again, a number that divided by any single digit integer will have a remainder of 1. Okay. So again, the key is try to, so in this case, this is already actually 1 already, so this is actually not too bad. So what you want to do, you want to minus 1. So when you minus 1, this becomes 0 mod 2, and it becomes 0 mod 3, 0 mod 4, 0 mod 5, 0 mod 6, 0 mod 7, 0 mod 8, 0 mod 9. Now when the remainder is 0, that means this is a least common multiple of these. Okay, so that means n minus 1 equal to LCM of 2, 3, 4, 5, 6, 7, 8, 9. Okay, to find the LCM, now you don't have to worry about 2 and 4 because 8 will take care of that. Okay, You don't have to worry about the 3 because 9 or 6 will take care of that. So all you have to do is worry about these numbers over here. So you can use a technique that we learned before. Okay. So 6 and 8. Okay, two of the, so when you're looking for LCM, as long as 2 of the number can divide, you can go and divide. So divide by 2, you get 5, 3, 7, 4, 9, and this can divide by 3. So you get 5, 1, 7, 4, 3. So your LCM will equal to all these numbers together. So you can use your calculator to multiply out. If you're not allowed to use calculator during the computation, then what you do is you go ahead and combine the easy numbers and try to group them. So 2 and 5 will give you 10. Okay, and then 3 and 7 give you 21, and 3 and 4 will give you 12. Then you can multiply this together, 21 times 12. So you got 252 times 10 will give you 2520. Okay. Then after that, to solve for n, you just have to plus 1 on each side. So you got n equal to 2521. Okay. Okay, let's go to 104. Actually, this is page 67, page 104. It says a store sold 72 decks of cards for A 67.9B. So the decimal doesn't really matter. Okay, you want to find A plus B equal to what? Okay, so now since this is the cost for 72 deck of cards, that means this is divisible by 72. Okay. So if it's divisible by 72, that means you can able to divide by 4, able to divide by 8, divide by 9. Okay. You also can. So from if it's divisible by 4, then the last 2 digits have to able to divide by 4, right? So that means the B have to be equal to 2, so they will give you 92 and 96. Okay, so from that we get that. Now, you also have to able to divide by 8, so we have to check. Okay, so you can see that the 792. So 792, you can check. 792 is good, so B equal to 2. But 796, if you put 6 over here, 796 is not divisible by 8. Okay, so 6 is out. So from here we can see that B equal to 2 right away. Okay, so we can simplify that more. So A 67.92. Okay, and also from here, actually you don't have to do all this. Notice that in order to divide by 9, the sum of digits have to equal to 9. So even without all these, okay, you know, if we kind of look ahead, divisible by 9, you notice that the sum of these digits, okay, is, so you actually can do the cancellation, right? So you can get rid of the 9, and 6, 7 is 13, okay. So 13, that means so A plus B had to equal to, so this is 13 already, so had to get 18, so had to equal to 5, or, and the next up would be 14. Okay, so these are some of the options. Okay, but because B had to equal to 2, so you know like cannot be this one. This one is no good, right? Okay, because A cannot be 12. Okay, so only option left is A plus B equal to 5. Okay, so again, in order to be divisible by 9, you have to sum of the digits. So that means A plus B have to equal to 5 or 14. But because B equal to 2, so this one is good, this one is no good. Okay. Okay, let's go to 105. Okay, so it says for each of the n equal to 84 and 88. So these are two separate problems. Okay, so this is for n equal to 84, and this is for n equal to 88. Find the smallest integer multiple of n whose base 10 representation consists of entire 6 and 7s. Okay, so all 6 and 7s. Okay, well, so 84 is equal to, if you break it down, this is equal to 4 times 3 times 7. Okay. So in order to be able to divide by 3 and divide by 7, okay, so divisible by 3 and 7, okay, we need at least 3 7s. Okay. So we need 3 7s. So right away we know that part of the answer would be 7, 7, 7. Okay. Now, in order to be divisible by 4, okay, we know that the last two digits, well, obviously you have to, the last digit had to be even, okay, because 4 is equal to 2 times 2, right? So in order to divisible by 2, we know that last digit had to be even, therefore the 6 had to be on the end, okay? And then we can check, okay? We can check, okay? So last two digits is divisible by 4, yes. Okay, and let's see. But because because we want to divide by 4, so therefore we need 7, 6 at end. Okay. So, but right now we have problem now, because now. This no longer divisible by, this one is not going to be able to divide by 7s. Okay, so you can check. So this one is no good. So we need to add more digits. Okay, so again, because in order to divide by 3, we can only have 3 7s or 6 7s or 9 7s. Okay, so what we need to do is we have to add more 6 onto it. Okay, so this one is no good. Okay. And so if you add 6 to it, so 7, 7, 6, 7, 6, okay? So you can try, see if this divisible by 7, okay, you can check. And so this one, if you try it, this one is no, okay? So again, these are just criteria for you to try, so number to try. But the 6 can move around, right? So this one you can move, you can put 6 over here, move over here, move over here, move different places. And so when you move the 6 over here, and this will be able to work. Okay. So the smallest number that can divide by 84 using only the 6 and 7s is this one here. Okay. So you can use this to get you started. Okay. So you can, in order to divide by 3 and 7s, okay, in order to divide by 3 using only 7s, you need to have 3 7s or 6 7s. So that's how we start. And since you want to divide by 4, divisible by 4, the last digit has to even, and this 2 must be able to divide by 4. Okay? So this will get you started, and you can try see if you can divide by 84. Okay? And if you cannot, then you have to add one more digit, 6. So you try put 6 over here, put 6 over here, put 6 over here. So another number we didn't try is this one here. Okay, so you have to try this one, see if it works. Okay, but again, because of this, we don't have to try this one because of this, we need to have a 76 at the end. 66 does not divide by 6. Okay, but you can try to start. So that way you put 6 over here, then you move the 6 over here, then you move the 6 over here. Okay, if it doesn't work, then you have to move the 6 to the front. So you have to do that. But if it still didn't work, you have to add another 6, so make it into a 6-digit number. Okay. So in this case, this is fine. Okay, now for 88, this is equal to 8 times 11. Okay. So again, in order to divide by 4, if it divisible by 4, okay, then we need 7, 6 at end. okay? So we need to have a 7/6. Now to be able to divisible by 11, we need to do the alternate digits, right? So in order to even out, we need to have a 7 and 6, okay? And now you have to try to fulfill the 8. Remember, in order to divide by 8, the last 3 digits have to be able to divide, right? And then you can check it out and see if anything works. And so this would be it. So it happened that this would be it. So again, this would kind of use a clue to get you started, to get you have some possibilities. Then you can check it out to make sure indeed that you're able to divide. Okay, let's go to 106. Page 67, number 106. It says when the number n is written in the base b, so when the number n is written in the base b, it's represented, okay, so n, when it's written in the base b, is equal to a, b, base b, okay? So this number in the base 10, when it's right in this way, is equal to that. And it tells you that a is equal to b minus 2, and b is equal to 2, okay? Okay, so now if it base b, this is going to be worth b to the 0, and this is going to equal to this is going to worth b to the 1, okay? So that means this number, so a equal to b minus 2, okay? So this is going to give you b minus 2, so a equal to b minus 2. But because this is in the 10th position of the base b, you have to times it by b to the 1 power. And you have to plus the b times b to the 0 power. Because this is the unit digit, so you have to times by 1. And this is the 10th or the b digit, so you have to times by b. Okay? And this will equal to n. So you work it out. So n is equal to b squared minus 2b plus, and it tells you b equal to 2, right? See the b equal to 2. So this is equal to 2, and this is equal to 1. So it'd be plus 2. Okay. And now, so you have this expression. So n equal to this number, okay, in base 10. So this is base 10 because we multiply everything out. This is base 10. So now when you're going to convert into the, so you want to write this number in the base b minus 1. So now you're going to, so you want to write this number, this n in the base b minus 1. So you have to use the long division, right? So you got b squared minus 2b plus 2. And you're going to do it in the base b minus 1. So you divide by that. So you're going to get b. So b squared minus b. Subtract. You're going to get negative b plus 2. And you're going to get minus 1. So you're going to get minus b plus 1. And you're going to subtract. And so you're going to get 1. So that's your last digit. And you have to keep doing that, right? So bring these things down. And so you're going to get 1. So b minus 1. So they give you 0. And put these things down. Right? This is the thing we learned from before, right? So n is going to be equal to 101 base b minus 1. Okay? So again, using the clue over here, you find out what the n is equal to, and then in base 10, and you divide by the base you're going to be using, and you end up with 101 for base b minus 1. Okay, let's go to 107. Okay, so you have the 8th root of 10,000 base A is equal to 10 base A, and you're looking for A equal to question mark. Okay, now because this is over here, so this is equal to a to the 4th power. Okay, so this is a to the 4th power. Because if this is base 10, this would be 10 to the 4th power. But because this is a, so it would be a to the 4th power. Okay, so you can think about base 10, right? So when you have 10,000, if this is base 10, this will equal to 10 to the 4th power, right? Because this is base 10. But because this is base a, so your base would be a to the 4. Okay, so base would be a. And this will equal to 10 base a. And so if you simplify this is going to be a to the 4 over a is equal to 10 base a. Okay. Now, but again, 10 in the base a would be just equal to a. Okay. Okay, and again, the reason for that is because when the base, when you have 10 base a, right? This is worth 10 a to the 0 power. This is worth a to the 1 power, right? So whatever the base is, right? And so that's where the a came from. And so now you can go and set it equal because now the base match, so exponent will match. So you got 4 over a equal to 1. And you can go ahead and cross multiply, so 4 equal to a, and that's it.